It's the advent of Cyber 2023, and we are on a mission to save Christmas. McGreedy, you are going down. I have the THM Army with me. Let's go. Yeah. I'm a pop a shell, but not what you think. Who am I root? Make it dead a leg sink. We are on a mission, we're here to save Christmas. McGreedy's going down, forget about the riches. Rumors gone around, McSkitty's got snitches. It's an insider threat, and everyone's suspicious. Recon McRed is hunting down a witness. He says he needs our help, so power on your system. Get your black hoodie, boot up the attack box. Hackers come together and take command of the SOC. It's the THM Army. McGreedy will get caught from the 0x1 all the way up to the gods. It is time. What is up, everyone? Welcome back to my live stream. My name is Tyler Ramsbey. We are on a mission to save Christmas. And hey, if you've been here in the past, you know that every single night throughout the month of December, we are going through TryHackMe's Advent of Cyber challenges on this mission to save Christmas. Now, like usual, have not done this room, have not looked at it, so we're going to dive into it blind and see if we can stumble our way through it. Before we do that, I want to say a special hello to everybody watching, saying hello to Zach and Justin and Z and Overgrown Carrot and Prince over on LinkedIn. Hopefully I hit everyone at least who has said something. Oh, Tony just commented over on LinkedIn, and we are live. For those of you who don't know, we are live on YouTube, LinkedIn, and Twitch at the same time, and I have to do my best to try to monitor all the chat. Z said no Christmas tie or hat. Yeah, good catch. I think my kids put it somewhere, so I'm not quite sure where it's at. But hey, one shout out to Overgrown Carrot. If you guys missed him, if you go to YouTube and just like type Overgrown Carrot, there's not that many people who go by that name. Has an incredible YouTube page, also has a Twitch channel that he streams. He did a really cool walkthrough of day 11 of TryHackMe's Active Directory scenario, but approach it from a different perspective and show some cool tools. So if you guys did not see that video, go to YouTube, look for Overgrown Carrot, check it out. I learned a lot from it. I think you will as well. So I just wanted to plug that and make sure y'all check it out. Now, without any further ado, let me share my screen and let's dive into things. We are in day 15, more machine learning type stuff. Let's dive on in. Over the past few weeks, Best Festival Company employees have been receiving an excessive number of spam emails. These emails are trying to lure users into the trap of clicking on links and providing credentials. Spam emails are somehow ending up in the mailbox. It looks like the spam detector in place since before the merger has been disabled or damaged deliberately. Suspicion is on McGreedy, which I think I mentioned that in my rap song. Everyone's suspicious, right? That part. Who is not so happy with the merger. Problem statement. McSkitty has been tasked with building a spam email detector using machine learning. She has been provided with a sample data set collected from different sources to train the machine learning model. What are our different objectives? So number one, different steps in a generic machine learning pipeline. Number two, machine learning classification and training models. Number three, how to split the data set into training and test data. Number four, how to prepare the machine learning model. And finally, how to evaluate the model's effectiveness. A lot of stuff today, ladies and gentlemen. All right, lab connection before moving forward. I did start the VM, but I noticed, let me see if I can grab it. Here's the VM here. I noticed we might want to have the whole screen, so instead of doing it on the side, I just made it full screen on that tab, as long as I don't get confused as I'm trying to switch tabs on my host machine. But we have that pulled up. Overview of Jupyter Notebook. Remember, we did a little bit with Jupyter Notebook in the beginning of Advent of Cyber, but Jupyter Notebook provides an environment where you can write and execute code in real time, making it ideal for data analysis, machine learning, and scientific research. In this room, we will perform the practical on the Jupyter Notebook. It's important to recall that we will need to run the code from the cells using the Run button or by pressing the shortcut Shift-Enter. Each step is explained on the Jupyter Notebook for better understanding. Let's dive into the details, and let's go ahead and look at this. So we have the spam detector playground. Let's help McSkitty. So it's going to walk us through this. And each one of these, I know this threw a few people off, including myself when I was first doing it. You have to like run this first because we have to import these things before we run this one, before we run this one. But hey, before we even look at the scenario ourselves, let's see if we can read this code and understand what's going on. So this should be pretty normal now. We've seen this a few times now with both machine learning and the Jupyter models we were going through before, and we're importing two Python libraries, NumPy and Pandas, but we want to refer to them as NP and PD in our code, so that's where the as NP and as PD work. We have our data collection, very simple. We have a data variable, and we're reading the email dataset CSV, and we're storing it in that variable. We have our test check data. We're going to print data head, got it. Data pre-processing. How long is this? Maybe I should just read through the room. I mean, honestly, as I'm looking at this now, we have X train, X test, Y train, Y test. If you guys and ladies did this one yesterday, I'm trying to blank on my words. Yesterday we did machine learning. We did very similar stuff. Just looking at this, a lot of it at least looks familiar to me. I know a lot of people on the day yesterday just copy and pasted the machine learning code, which is fine. Like, you still completed the scenario, but I do just want to remind everybody, the goal when you're doing a TryHackMe room or Hack the Box Academy, whatever it is, the goal is not to get the flag, which I know sounds confusing. The goal is to learn. So even if you do a CTF, you don't even get user or don't even get root, but you learn something in the process, hey, that's a win. Truly, that is what matters. It's not about getting the flags. Those are a cool reward, but really the goal is learning. So make sure when you go through this stuff, you slow down, you read the code, and try to understand what is going on, testing the model, and then we're going to do some test emails. Okay, cool. Now that we have a good overview, now we can look at the scenario. Exploring machine learning pipeline. A machine learning pipeline refers to the series of steps involved in building and deploying an ML model. These steps ensure that data flows efficiently from its raw form to predictions and insights. A typical pipeline would include collecting data from different sources in different forms, pre-processing it, and performing feature extraction from the data, splitting the data into testing and training data, and then applying machine learning models and predictions. Got it. So we have ingestion. We're going to clean it up, we're going to pre-process, we're going to model, and we are going to deploy. So step 0, importing the required libraries, which you saw that. Before starting that, we need to import these libraries, so let's go ahead and do that up here. Right here. And in order to run that code, I think it's Shift-Enter. Yeah, okay, you're right, Z. I'm pretty sure it's Shift-Enter as well. Okay, we ran that code. Let's do our spam email detection in the following steps. Step 1, data collection. This is the process of gathering raw data, so ingestion is what we're doing now, from various sources to be used for machine learning. This can originate from numerous sources, etc., etc. We're reading from the email data set, which we should be able to see the raw data here. All right, so here's our raw data. Guys, I'm going to sneeze. I'm going to try not to sneeze into my microphone. Okay, cool. I didn't sneeze. That's a win already. But that's our data collection. So on this, we can do Shift-Enter as well. And we have now ran that. We have successfully collected the data. Test check data set. Let's review the data set we just imported. The category column contains the email classification, and the message column contains the email body as shown below. All right, let's see if we get that expected output. There we go. So we have our classification of spam. So this message is brought to you by blah blah. Spam. Ham, we made it. ETA at Tauntaun is 12:30. Spam, you are chosen. Receive a $3.50 gift card. Ham, you don't put that stuff on the rows to keep blah 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 blah. Data frames provide a structured and tabular representation of data that's intuitive and easy to read. Using the command below, let's use the pandas library to convert the data into a frame. It will make the data easy to analyze and manipulate. So that's this one right here. So we're just doing that, and then we're printing it out to the console. Yeah, I agree with Overgrown Carrot. We should get the gift card. All right, so easier to read, easier to understand. Let me make sure I'm not missing anything on LinkedIn. In order to see LinkedIn chat, y'all, I have to refresh it every time, which is annoying. But and then it tries to play the volume. So if you just heard myself talking, I apologize. I'm gonna turn desktop audio down so that doesn't happen. All right, I'm not missing anything on LinkedIn. How about YouTube? Nope. All right, good. Let's keep moving. Here we go. Expected output, which we did. That all looks good. All right, data pre-processing. So this must be the cleaning, right? Oh no, we're past the cleaning. The DF was the cleaning. Now we're at pre-processing. Got it. Data pre-processing refers to the techniques used to convert raw data into clean, well, we are cleaning it then. It's kind of one and the same. Into clean, organized, understandable, and structured format suitable for machine learning. Given that raw data is often messy, inconsistent, and incomplete, pre-processing is an essential step to ensure that the data feeding into the ML models is relevant and of high quality. Here are some common techniques used in data pre-processing. So we have cleaning, correct errors. I'm not going to read through all of this. Normalization, standardization, feature extraction. So that's transforming arbitrary data into numerical features. Okay, that makes sense. Dimensionality reduction, reducing the number of variables. Got it. Discretization. They're just making words up at this point. Transforming continuous variables into discrete ones. Text processing, tokenization, imputation, feature engineering. All right, so I recognize some of these terms from our machine learning stuff yesterday. Utilizing count vectorizer. Machine learning models understand numbers, not text. This means the text needs to be transformed into numerical format. Count vectorizer, a class provided by scikit-learn, or scikit, I should say, because it's science, scikit-learn in library in Python, achieves this by converting text into a token count matrix. It is used to prepare the data for the machine learning models to use and predict decisions on. Here we're asking the count vectorizer function from the Scalene whatever library. All right, let's do that. So this is really just the room right here. So from that, we're importing that. Got it. And now we're using our count vectorizer thingy to pre-process the data, make it so it's tokenized. All right, and that's what it looks like now. Train/test split dataset. It's important to test the model's performance on unseen data. By splitting the data, we can train our model on one subset and test its performance on another. That makes sense. Here, variable x contains the dataset. We will use the functions from that library to split the dataset into training data and testing data as shown below. It's like a control group. From that, blah, blah, y equals df classification, and then we have all our crazy x train, y train stuff. X, the first argument to train test is the feature. Let's just go do it ourselves. The variable x contains the data set. We'll use the functions. Okay, so we kind of understand that kind of. I don't really understand it, but we're going to pretend like I do. X, the first argument to train test split is the feature matrix X, which is you obtain from the count vectorizer. Obviously, guys. Y, the second argument is the labels for each instance in your data set, which indicates whether message is spam or ham, and test size. Okay, so 20% data should be kept as test set. So that's what's splitting it for the data. I got you. And it returns 4 values. X train, used for testing. X test, used for testing. Y train, corresponding labels. So I'm slowly understanding machine learning. I wouldn't be able to do it myself, but I know a lot of people were complaining about this like heavy theory stuff, but part of that is like people just don't want to read, right? Reading is good for you. I assure you, it's not going to kill you. Model training. Now that we have the data set ready, the next step would be to choose the text classification model and use it to train on the given data set. Some commonly used text classification models are explained below. We have the naive Bayes classifier. Okay. To support vector machine. Separate different classes. Logistical regression. I'll let you kind of read this on your own. Decision trees. Okay, got it. Random forest. Typically train the bagging method. I think about bagging my lawn. Gradient boosting machines, GBMs. Building strong predictive models. So outperforms random testing if tuned correctly. And the K nearest neighbors, KNN. Each data based on the majority vote of its neighbors. So it's a democracy. All right. What up, Daniel? Thanks for joining. Model training using naive Bayes. Naive Bayes is Oh my, that's hard to say. Naive Bayes is a statistical method that uses the probability of certain words appearing in spam and non-spam emails. So like gift card, I suppose, to determine whether a new email is spam or not. So let's say we have a bunch of emails, some labeled as spam and others as ham. The naive algorithm learns from these emails. It looks at the words in each email and calculates how frequently each word appears in spam or ham emails. For instance, words like free, win, offer, lottery might appear more in spam emails. It then calculates the probability of the email being spam based on the word it contains. When the model is trained and gets a new email that says, for example, win a free toy now, then it thinks win, spam, free, probably spam, toy, might be neutral. After considering all the words, it calculates the over probability of the email being spam or ham. If the calculated probability of spam is higher than that of ham, the algorithm classifies the email as spam, otherwise it's classified as ham. Let's use naive Bayes to train the model, as shown below. So from that thing, import multinomial NB, so that must be the naive Bayes. We're setting our CLF variable based on that function, and then we have our X train and Y train, so those are our test data from above. I got you. This is where the actual training of the model happens. The fit method is used to train or fit the model on your training data. When we call the fit method, the multinomial NB model goes through the data and learns patterns. In the context of naive Bayes, it calculates the probabilities and likelihoods of each feature, word, or token being associated with each class, spam or ham. These calculations are based on Bayes' theorem and the assumption of feature independence given the class label. Once the model has been trained with the fit method, it can be used to make predictions on new, unseen data. Step 5, model evaluation. After training, it's essential to evaluate the model's performance on the test set to gauge its predictive power. This will give you metrics such as accuracy, precision, and recall. So from that, import that, our Y prediction. We have a new variable here based on our CLF predict on X test, and then we're going to print it, and that's the expected output. All right. Precision, recall, FL score, support. All right. The classification report function takes in the true labels, Y test, and the predicted labels and returns a text report showing the main classification metrics. So what are these? Well, precision, this right here is the ratio of correctly predicted positive observations to the total predicted positives. The question, that is a very confusing sentence. Let's read it again. This is the ratio of correctly predicted positive observations to the total predicted positives. Got it. The question it answers is, of all the samples predicted as positive, how many were actually positive? So, in other words, is it correct or not? Recall, sensitivity, the ratio of correctly predicted positive observations to all the actual positives. These sentences, y'all. It answers the question, of all the actual positive samples, how many did we predict correctly? Wait, isn't that the same as precision? Oh well. F1 score, the harmonic mean of the precision and recall metrics. It gives a better measure of the incorrectly classified cases than the accuracy metric, especially when there's an imbalance between classes. Support is the number of actual occurrences of the class in the specified data set. Ooh, gotcha, that makes sense. Accuracy, the ratio of correctly predicted observations to the total observations. Isn't that the same as recall and precision? Those must not be the same, but they're the same in my head. Macro average, this averages the unweighted mean per label, and weighted average averages the support weighted mean per label. All right. The report gives us insight into how well our model is performing for each class and overall. If it was a Tyler model, it would be like 30%, I think, of understanding, but that's just because the Tyler model is broken. Testing the model. Once satisfied with the model's performance, we can use it to classify new messages and determine if they are spam or not. Today's offer, blah, blah, text yes, now, blah, blah. It should be spam. The email is spam. Beautiful. What's next? Well, McSkitty is happy that a workable spam detector model has been developed. She has provided us with some test emails in the file test email CSV and wants us to run the prepared model against these emails to test our model results. Test data. So what we're going to do is read from that file. So we're going to I assume fill that in. Maybe that's what we have to do. We just have to replace that with test email, so it reads from it. Data head. Is there anything else we have to fill in? Let's update the following code and include the test emails file. Okay, I got you. Was it email or emails? Emails, got you. All right, let's run. 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 YOLO. It looks like it did a pretty good job. All right. Conclusion. This is it, folks. From this task, from the practical point of view, we have to consider the following points to ensure the effectiveness and reliability of the model. Number one, continually monitor the model's performance on a test data set or in a real-world environment. Number two, collect feedback from end users regarding false positives. Number three, use this feedback to understand the model's weakness and areas for improvement. And finally, deploy that beast into production. All right, what is the key first step in the machine learning pipeline? Data ingestion, is that what it is? I'm pretty sure it's ingestion of something. The first key step, ingestion, right? Import, data, oh, data collection? Same thing, bruh, technically. Which data preprocessing feature is used to create new features or modify existing ones to improve model performance? Which data okay. Create new features. Data create new features. Feature engineering. During the data splitting step, 20% of the data set was split for testing. What is the percentage weight average of precision? What is the percentage weightage average of precision of span? Oh my goodness, what kind of worded question? What? Let me just read that again. During the data splitting step, 20% of the data set was split for testing. What is the percentage weightage average of precision of spam detection? That's harder to say than my rap song. That answer should be right up here. 98. How many of the test emails are marked as spam? That was the support. 98. Oh. How many of the what emails? Test emails are marked as spam. 3. One of the emails detected as spam contains a secret code. What's the code? Bruh. You guys see the secret code? One of the emails marked as, oh, as spam. So there's only a few. There's only 3 emails to choose from. Could just expand this if it lets me, and then we'll just look at the emails. Here it is. I hate festival. I found it. Can I not copy? Really? Is there not like note-taking software on here? Okay. Cool. All right, I'm going to type it on my other screen, guys. I hate boom. If you enjoyed this room, check out the fishy module. I always like to see if I've done these. I apparently did everything but the last one. Okay. Have to come back and do that sometime. But there we go, ladies and gentlemen. We have finished whatever day it is today, day 15, I think. Day 15, machine learning, jingle bell spam, machine learning saves the day. And hey, as usual, I will be back, same place, same time tomorrow night. We are going to continue on our mission of saving Christmas. Want to say a big thank you to everyone who took the time to join me, whether you're watching me live on stream or maybe after the fact on YouTube. Yo, thank you for taking the time. Hopefully you found this helpful. Want to make sure I'm not missing anything on chat before I sign off, and I don't think I am. So, hey y'all, happy Friday. Hope you have an incredible weekend, and I will see you all tomorrow evening. See ya.